Assalamualaikum and welcome to our Group E ECC3121 final project presentation. And my name is Bimo and I will get to our presentation. So the project itself is called Blood Clot Formation Detector. To the next slide, please. So this is our group member. My name is Bimo and I'm the group leader. And there is Farid, Adham, Amir, Suraya, and Aida. For the next slide, I will pass it to Aida.
Okay, so for the introduction, a vaccine is a substance that trains the body's immune system to protect itself against the disease. Even though it is safe and effective, there are certain groups of people who are not allowed to get the vaccine due to age and health concerns. And there are also several reports of the occurrence of blood clot in some of the vaccinated people. It is related to the thrombocytopenia syndrome or TTS when the body has low levels of thrombocytes. Therefore, precautionary action should be taken before people get vaccinated so that they can prevent this type of problem. Next, I'm going to pass to Farid.
Okay. Okay. Thank you, Aida. So the main problem for our doing is blood clot formation after the vaccination. So blood clot is commonly a process if the blood vessel is bleeding or it is an act of inflammatory where leukocyte detect presence of pathogen. So how blood clot form in vaccination? In some person body, they have lower number of platelet compared to normal number of platelet, which is called TTS, like Aida explained. So this antibody appear and make the platelet to clump together and form a blood clot. It will be more sensitive to the COVID-19 protein. So at the right side, we can see the example of blood clot in the brain that happened in COVID-19 vaccination after the vaccination report. So next slide. So we will using the MRI scanner to overcome the blood clot formation. Sorry. So here is the typical MRI scanner, the component. So there is a big magnet and also a magnetic. There is coil. Sorry, and also there is radio frequency transmitter and also computer to detect image. Next slide, please. Thank you. So MRI mechanism. So we know that in our body tissue we have many water atom, water proton. Sorry. So all proton have become aligned with the net magnetization from the magnet because the magnet will produce a strong electromagnetic field. Sorry. So after that, when they have all aligned, the radio frequency transmitter will emit radio frequency excitation pulse that will apply to the aligned proton. So the aligned proton will become excited by the radio frequency pulse and it will flip a bit. So when it is flipped a bit, the radio frequency transmitter will turn off, and the and the proton will become aligned to the magnetic field, the first one. So when it want to go to the magnetic field, the first one, it called relaxation time. So in this relaxation time, it will emit energy, and the energy will be received by the computer, and computer will use Fourier transform to change it into the image. So I will pass to Aryo Bimo next.
Thank you, Farid. And then for this occasion, we will talk about the formulation of this project. So first of all, after the electromagnetic wave is released to the body, the nucleus and the proton inside the body will be spinning. So the spin itself is in certain speed and frequency that can be counted by the Larmor frequency. The Larmor frequency itself is consists of omega equals to gamma times B. The omega is Larmor frequency, and then the gamma is the gyromagnetic ratio, and then the B is the magnetic field strength inside the scanner. After we count the Larmor frequency, we will go to the T1 relaxation, or can be known as the spin lattice relaxation. T1 relaxation is the measurement of how the magnetization factor converts to its initial phase. In other words, we can say that it is when the nucleus going back from the high energy state to the ground state. The T1 relaxation formula consists of Mt equals to Mmax times 1 minus e to the power of minus t over T1. The Mt is the magnetization at the time t. Mmax is the maximum magnetization during the initial phase, and the T1 itself is the T1 relaxation. Moving to the next slide. We can see the result of our project. So at the left side, at the top, there is table. The table itself is described how long does it take for each tissue to reach the T1 relaxation times. So at the top, we have water with 4,000 milliseconds, gray matter in 900, muscle in 900, liver in 500, and so on. At the bottom of the table, we have the graph. The graph consists of, for the y-axis is the longitudinal magnetization, which in percentage, and then the x-axis is the time that is taken to achieve the relaxation times. So the T1 relaxation times actually occurs when the longitudinal magnetization is in 63%. So the yellow part is when the fat tissue is achieve the relaxation times, and then the blue one is the water. As we can see, the fat occurs T1 relaxation times faster than the water because the fat has condensed material compared to the water. And we assume that the blood clot occurs the relaxation times between the fat and the water because it has gel-like shape. To the right, we have the result of the scanner. At the top, we have the brain scanner. So the T1 relaxation time can describe the image that is available during the scanner. So the faster T1 relaxation times, the darker the image is. So as the green arrow pointed, the dark one describe the blood clot. To the bottom one, we have leg scanner, which the yellow arrow illustrate the blood clot inside the leg. To the next slide, I will pass to Adham.
Thank you, Bimo. I will proceed with our theory and design for our blood clot formation detector. So for the feature of our machine is we have one main feature which is detecting system. So as you can as what been said by Farid, our machine is based on MRI scanner. So what happened during the detecting system? So first, big magnet in our machine we will produce a powerful magnetic field which it will go through the patient bodies. The magnetic field will cause the proton in patient body to align with the magnetic field. And then when a specific frequency field between 2 kilohertz to 900 megahertz introduced by the field call to the patient body, the proton will spin out of equilibrium against the magnetic field. And when the frequency will be turned off, the proton will the proton will be realigned with the magnetic field and release energy. So for the time the proton realign to the magnetic field, we will calculate the energy will be measured. Then due to that, the difference between the various type of tissue will be able to identify according to those magnetic fields. Um, the energy will be sent a signal to a computer. The computer use a mathematical formula that we say by Aryo before, and it will convert the signal to an image. So for our design of our machine, you can see in this right side of slide, our machine is consists of magnet, scanner, 2 kilohertz to 900 megahertz field course, and guiding course. The special of our blood clot formation detector is it is more compact, and it is the size of this machine is smaller than the MRI normal scanner. So I think that's all for us. Thank you very much.